Good evening. Regarding structural analysis 1, the subject code 20C 502, we see the unit 3 arches. So, in this, we have to see the types of arches. What is an arch? Arch is a structure constructed of wedge shaped unit. Here, the figure shows this portion is called arch and it span and opening to support the weight of the wall and other superimposed loads. So here the above portion, this portion is above the arch, so this portion is entirely supported by the arch. These are terminologies that are used in arches. Intrudus, it is the inner curve of the arch, and extrudus is the outer curve of the arch, and the soffit, the inner surface of an arch, and Vousets, these are wedge-shaped units. The crown, this is called a crown. This is the highest part of the extrudus. And abutment, the end point of the arches. Here, there are two end point. This is called abutment. The springer, it is the first visor at a springing level. Here, the intermediate support of an arch. Archet, it is a row of combination of arches. This type of arcades are provided in bridge, etc. And the haunch, the lower half of the arch between crown and skew back. This is called a haunch. So arches are classified according to their shape, number of centers, workmanship and materials used, etc. So classification of according to shape. This is a flat arch, this is segmental arch, semicircular arch, horseshoe arch, pointed arch, Venetian arch. Florentine arch, relieving arch, stilted arch. This type of arch is called a stilted arch. Semi-elliptical arch. The flat arch. Flat arch is an equilateral triangle with an intrudus at base, the angle of 60 degree. Used only for light loads. This is the weakest arch. Not much amount of load that can be taken compared to the circular or parabolic arch. Segmental arch. This type of arch lies between the springing line and thrust transfer to the abutment is in inclined direction. This thrust means in a simply support on continuous beam. We told there is a reaction, and here this is called a thrust. This is the most common type of arch. And a semicircular arch. Center line on springing line. The shape of arch is semicircle. Thrust transfer to the abutment is preferably only in vertical direction. So the difference between segmental arch, the thrust transfer to the abutment is in inclined direction, and for semicircular arch, the thrust transferred in vertical direction. And horseshoe, the shape of the arch is like horseshoe. The arch has the shape of the horseshoe, incorporating more than a semicircle, mainly used for architectural consideration. Not much amount of load that can be transferred by the horseshoe arch when compared to the circular or parabolic arch. This is a pointed arch, also known as Gothic arch, consists of two arcs of the circle meeting at an apex. This portion is called apex. The triangle form may be equilateral or isosceles triangle. Equilateral triangle means the three sides of the triangle is equal. That is called equilateral triangle. Isosceles triangle means the two sides of the triangle are equal and another side is different from the other two sides. These are the four types of the fixed support, and there are two hinged, and this is one hinged, and this is three hinged arches. Introduction. Mainly three types of arches are used in practice: three hinged arch, two hinged arch, and hingeless arch. In 19th century, three hinged arches were commonly used for long span structures. The development in structural analysis for long span structures starting from late 19th century adopted two hinges and hingeless arches. Two hinge arches is statically indeterminate structure to the first degree, and usually the horizontal reaction is treated as the redundant and is evaluated by the method of at least work. Arch. Arch is a curved beam or structure in vertical plane. Normally, the simply support on cantilever are horizontal, but the curve is a curved beam. Subject to transfer loads, which act on the convex side of the curve and resets the external loads by virtue of the thrust. It is subject to three restraining forces. That means thrust, shear force and bending moment. This is the actual arch and this is called theoretical arch. The W1, W2, W3 are the load transferred by the arch. This is a horizontal thrust and a vertical thrust. This is the difference between 2 hinge and 3 hinge arches. 2 hinge arches are statically determined to first degree and 3 hinge arches statically determinate. Might development are temperature stresses. Increase in temperature causes increase in central stress, no stresses. Structurally more efficient, easy to analyze, but in construction, the 3 hinge arches, the central hinge may involve additional expenditure. 2 hinge arches will develop stresses due to sinking of supports. Since 3 hinge arches is an indeterminate, more stresses due to support sinking. Types of arches according to support conditions. 3 hinge arches hinges at support and at the crown. A 3 hinge arch is statically determinate structure. This is called rise, this is crown, and this is called spring. Hinged at the spring and the crown. 2 hinge arches hinged only at the support. It is indeterminate structure of degree of determinacy equal to 1. This is the rib of the arch. This is the rise, span, arch, span, hinges at the support. Single arch, hinged arches, and fixed arches are hingeless arch. Support are fixed. It is statically indeterminate structure. The degree of indeterminacy is 3. According to their shape, circular, curved or segmental arch, parabolic arch, elliptical arch, polygonal arch. According to their base of the material, steel arches, reinforced concrete arches, masonry arches, brick or stone, etc. According to the space between the loaded area and the rib actions, open arch and a closed arch. The closed arch is called a solid arch. 3 hinge arches is a statically determinate structure. 3 hinges at crown and 2 other hinges are at each abutment. Most used for long span bridges. Analysis of 3 hinge arches, parabolic arches. Bending moment at the crown hinges 0. Arch have 2 reaction at support, one horizontal and one vertical. Need for 4 equation to solve and find the unknown reaction. This Fy is called vertical and Fx horizontal. V is called vertical reaction. Mz stands for moment. We can use static equilibrium equation, and in addition to the bending moment at the crown, hinge is equal to 0. For symmetric parabolic arch, the rise is a rise y equal to 4h by L square x into L minus x. Here yc is the r equal to radius or rise of arch. L equal to length of the arch or span. The internal forces acting in the arches are normal thrust Nx, that is Vx sin theta plus h cos theta, and radial is Rx Vs sin theta plus minus h cos theta. Slope of arch theta equal to tan inverse of 4h by L square into L minus 2x. Resultant Ra equal to root of Va square plus Ha square. Here Fx and Rx stands for shear force in the arch. Fy or Nx stands for thrust in the arches. Theta is slope of arch axis at P. B equal to vertical shear at P. The C stands for thrust at P. M stands for bending moment at P. Here on example problem, a 3 hinge arch has a span of 30 meter and a rise of 10 meter. The arch carries UDL of 0.6 kN per meter on the left half of this span. It also carries two concentrated load of 1.6 kN and 1 kN at 5 meter and 10 meter from the right end. Determine the reactions at the support. First, horizontal B and vertical A. In horizontal B is 4.275 and the vertical reaction is 4.225. The load is provided 0.6 kN per meter, and here 1 kN and this 1.6 kN from 5 meter and 10 meter from the right end. So first summation of Fx equal to 0, that means HA minus HB equal to 0. So HA equal to HB. For vertical reaction, summation of Fy equal to 0, Va plus Vb equal to 0.6 into 15. That means the length acting is totally span of the arch is 30 meter, and here A to C, that is 10 meter. So 0.6 into 10. Here 30 by 2 equal to 15. So 0.6 into 15 plus 1 plus 1.6 is 11.6. Summation moment at A equal to 0 minus Vb into 30. Vb means the vertical reaction at B into the total distance 30, and here 1.6 into 25. That is the 1.6 into 15 plus here 10, so totally 25, and 1 into that is 20, and 0.6 into 15 into 15 by 2, that means 7.5 equal to 0. So vertical reaction B equal to 4.25 kN, and the vertical reaction at A equal to 11.6 minus 4.25 equal to 11.6. and A equal to 7.35 kN. So moment at C equal to 0, here we can find HB and HA. Moment at C equal to 0, that means HA and HB can be calculated. To find the total reaction, RE equal to root of HA square plus VA square, that is 8.5 kN. So alpha at A, that is angle of the resultant is 59 degree 0.82. RB equal to root of HB square plus VB square is 6.02 kN, and alpha at B equal to 44.83. So thank you.